Question number 57. Object X collides with object Y. Y is initially stationary. Tracks of the colliding particles after the collision is shown. Which collision is allowed? For solving this question, you need to know a little bit about vectors. Without understanding vectors, you cannot do this. Okay. In vectors, now see what is happening over here. There is a two-dimensional collision. How does a two-dimensional collision appear? It appears like this. So initially, this is your X over here. Y, I will draw a line here, a dotted line like this, and Y is somewhere over. Y is somewhere over. Okay, and this is Y over. I will assume that both the objects are initially stationary. Sorry, both the objects have the same mass. Both the objects have the same mass. Okay. So as a result of it, when it goes over here, it hits here and hence it experiences a two-dimensional collision. See, a one-dimensional collision is characterized when the center of this object and the center of this object are being joined together by a single line, and the collision happens along that line. Okay, that is what we call as a one-dimensional collision. In the two-dimensional collision, that is not happening, but instead, okay, the centers do not coincide, but still there is a collision happening. This collision can happen by physical contact or maybe due to the fields. It can happen to anything. Let us say if this is two charges, then might be this charge is here and this charge is somewhere over here. So it can there need not be any physical contact. It can just come over here and it can go away like this, right? This is what you have seen in case of your Rutherford's model. Now this is physical contact over here. It hits over here and it goes. Okay, so therefore might be this might go like this over here. Okay, sorry. Y is going. Y might go like this, or Y might go like this, right? And then Y might go like this. Y might go like this, and Y might go like this. Okay, as evidenced by the four diagrams. So this is your A, this is your B, this is your C, and this is your D. Okay, but X will always go like this. X will always go like this. Now, which of the options is correct? Now, how do you solve this? Now, what is the clue given here? The clue given here is which collision is elastic. What do you mean by elastic? Elastic means conservation of momentum is always obeyed. In addition to it, conservation of energy is also obeyed. Okay. This is what is called as elastic. Now, towards it. Now, when you say conservation of momentum, now what do we have here? We have a particle which is coming, hitting over here, and then it can go like this, whatever it is. Okay. So, towards it. Now, when you say conservation momentum, you can say initial momentum of this particle is mu. This should now be equal to, when this comes and hits over here, this velocity could be mv1 plus mv2. Okay, what is that I have written over here? I can say along the x-axis, mu is nothing but the momentum along the x-axis. Now, after hitting, maybe X has a velocity of v1. X has a velocity of v1, so therefore its momentum is mv1, and Y has a velocity v2. But okay, let us say for example if it's v2, then I will write this as m times v2, which is nothing but the momentum as seen by the particle. So this should be obeyed, or you should use u equal to v1 first. This should be first. Okay. Next is conservation of momentum is second thing that should happen is that the energy should be conserved. What do you mean by energy to be conserved? It means the initial kinetic energy of the X is nothing but half mu square. It should now be equal to the kinetic energy of the particle after collision, which is the half mv1 square plus moment kinetic energy of the particle after collision for Y also should be half mv2 square. Okay. When I do this, now what will happen? This half m will cancel everywhere, and thus you will get u square is equal to v1 square plus v2. This is what I get. Now what we do is, let us take this value of u and substitute over. Okay, u equal to v1 plus v2. Same time u square equal to v1 square plus v2 square also. When I do that, what do I get here? v1 plus v2 the whole square is equal to v1 square plus v2. Okay, but of course it cannot be simultaneously true every time. Let us see under what conditions this can be true. Now v1 square plus v2 square plus 2v1 v2 is equal to v1 square plus v2 square. And you see v1 square, v1 square, v2 square, v2 square cancels. So what is left out here? 2v1 v2 is equal to 0. Which means what? If at all, if this condition is true, that means the initial velocity should be equal to sum of the final velocities, and the total kinetic energy is also conserved. COM and COE both are satisfiable. In that case, this 2v1 v2 should be equal. What is v1 v2? Your v2 are two vectors. Okay. So therefore, in other words, I can now say v1 into v2, v1 into v2 equal to 0. Or when will this be possible? When two vectors, product of two vectors equal to 0, means, see, either v1 should be 0 or v2 is equal to 0. Unfortunately, none of them are 0, right? So, because both of them are moving, right? This is v1 and v2 are the velocities after the collision. So, both of them are moving. So, you can now say maybe v1, v2 cos theta is 0. What do you mean by that? What is theta here? Theta is the angle between v1 and v2. So, which means that if the angle between v1 and v2 is equal to 90, okay, the angle between, if angle between them is equal to 90, then v1 v2 cos 90 is equal to 0. So this is possible. Now if you look at this is your v1, your v2. Is the angle 90 here? No, there is some angle theta is not 90. If you look at this over here, this is v1, this is v2. The angle here is 90 degrees. So these should be your right answer. Let us look at the other options also. Look at this here. This is v1 and v2. This is your v1, your v2. Is it 90? No, this is some other obtuse angle. So definitely this is also incorrect. Look at this here. v1 and v2. v1 is this one, v2 is this one. So this is equal to 180 degrees. This is also not equal to 0. As a result of it, the B is the right answer. Okay. This particular solution through vectors is really a tedious one. It's you should know, if you know vectors, then such kinds of problems can be easily solved.